Welcome back to the Explainer. So, have you ever opened up your class 9th math textbook, stared at a page full of equations, and felt like you were looking at some unbreakable alien language? I mean, all those weird little hooks, tiny floating numbers, variables trapped inside boxes, it is totally intimidating. But here's the secret. Math isn't actually trying to confuse you. It's just a secret language that's waiting to be decoded. And today, we're going to become master code breakers. We are diving straight into topic 1.3, Radicals and Radicands, and we're going to crack this code together.
Okay, let's dive into this. Here is our roadmap for today. Section 1, decoding the radical sign. Section 2, radical versus exponential forms. Section 3, mastering radical properties. Section 4, solving textbook examples. And finally, Section 5, conquering exercise 1.3.
So before we get bogged down in the technical definitions, what is actually hiding underneath that radical sign? Well, think about a massive tree right outside your window. The branches and the leaves are obviously what you see on the surface, but the true foundation, the literal thing anchoring that entire structure to the earth, is the root system hidden underground. In math, when we're looking for roots, we are doing the exact same thing. We're digging down underneath the surface number to find the hidden foundation that built it. Just keep that real-world analogy in the back of your mind as we go.
Section 1, decoding the radical sign.
All right, here is your core vocabulary straight from the source. First up, the radical sign. You know it, it's that familiar checkmark-looking symbol, basically mathematical shorthand for taking a root. Next is the radicand. In our general formula here, this is represented by the letter A. The radicand is simply the number or the expression that's literally living underneath the radical sign. Finally, the index, represented by N. This is that tiny little number sitting right on the shelf of the radical sign, and it tells us exactly which root we're digging for. Are we looking for a square root, a cube root, a fifth root? The index tells you. So the crucial point here is this. You have to be incredibly careful not to confuse the index, which sits snugly inside the V of the symbol, with a large coefficient that just sits on the outside multiplying the whole thing. Remember, the index is a structural piece of the code itself.
Section 2, radical v's exponential forms.
Okay, check this out. On the left, we've got the radical form, x equals the nth root of a. Now, on the right, we have the exponential form, x equals a to the power of 1 over n. I really want you to burn this visual into your memory because here is the ultimate secret. These two equations, they mean the exact same thing. Seriously, there is zero mathematical difference between them. The radical sign is literally just a visual code for a fractional exponent. If you have an index of n, it just becomes a denominator of n in a fraction, right up there in the exponent. Once you realize that radicals are just fractions in disguise, the whole system just unlocks.
Section 3, mastering radical properties.
Now what's really interesting here is how incredibly flexible these rules make our math. Whether we're dealing with a standard square root or an nth root, the properties of multiplication and division allow us to break apart or combine these numbers beautifully. See, if you have the nth root of a times b, you can just split that up into the nth root of a multiplied by the nth root of b. And the exact same thing goes for division. It's a real game changer because it means if a number under the radical is just too big or messy, you have the mathematical authority to break it down into smaller, much more manageable chunks, as long as you respect the index, of course.
Section 4, solving textbook examples.
All right, time for some live decryption. Here is example 1 from the textbook, where we are transforming radical expressions into exponential forms. Let's look at the cube root of 18. Step 1, identify the index. Easy, it's clearly a 3. Step 2, take the radicand, which is 18, and wrap it safely in parentheses so we don't accidentally lose anything. Step 3, apply the index as a fractional exponent, so that index of 3 just swings right around and becomes the denominator, giving us 18 to the power of 1/3. Oh, and a quick pro tip based on the source text here, if you ever see a radical sign without an index actually written there, like a plain old square root, there's always an invisible 2 hiding right there. Never ever forget the invisible 2. Let's completely reverse the process for example 2. Now we're rebuilding the code, going from exponential form backward into radical form. Take a good look at the fraction 5/7 raised to the power of 3/5. Step 1, look at your fractional exponent, which is 3/5. Step 2, the denominator of that fraction, the 5, drops down and becomes our radical index. It just steps right into the V of the radical sign. Step 3, the numerator, the 3, stays exactly where it is, acting as the exponent for the entire radicand inside the house. So we end up with the 5th root of the quantity 5/7 cubed. the denominator becomes the index. It is literally that consistent every single time.
Section 5. Conquering Exercise 1.3.
Okay, let's ramp up the energy. We are going to knock out every single question in your homework exercise right now. Question 1 is a great warm-up. Write the base and exponent. For 3 to the 4th power, the base foundation is 3, the exponent is 4. Moving on to 1/2 cubed, the base is that entire fraction, 1/2, acting as a single unit, and the exponent is 3. Finally, -30 to the 20th power. The base is -30, the exponent is 20, and this brilliantly illustrates how super simple it is to identify the base foundation and the power before we even get to the tricky radicals. It's all about just identifying the roles the numbers play. Moving fast, question 2 asks us to identify the radicand and index. Let's drill those definitions. For the cube root of 5, the radicand, remember the number trapped inside the house, is 5, and the index is 3. Next up, the 4th root of x over y. The radicand is the whole fraction, x over y, with an index of 4. And honestly, no matter how many random letters they throw at you, like look at the 5th root of x squared yz. Everything trapped inside is your radicand. So x squared yz is the radicand, and the index is 5.
Powering right through question 3, transforming these into exponential forms. First up, the square root of 3/4. Remember that invisible 2. This simply becomes 3/4 to the 1/2 power. For the square root of x over y to the 5th, well, the 5 is our numerator, the invisible 2 is our denominator, giving us x over y to the 5 over 2. Cube root of y over x to the -5, super simple, y over x to the -5/3. The 7th root of yz just becomes yz to the 1/7. And the 9th root of 27 is, you guessed it, 27 to the 1/9. Notice the pattern here? The index always, without fail, slides underneath to become the denominator. Continuing with question 3. Cube root of -64 squared. The index 3 becomes the denominator, so we get -64 to the 2/3. Now, don't let the letters scare you off. For the cube root of 1/2 to the power of m, those variables are really just placeholders. It follows the exact same rule, 1/2 to the power of m over 3. The 5th root of xy cubed becomes xy to the 3/5. And wrapping up this specific section, the cube root of 4/3 simply unlocks as 4/3 to the 1/3.
All right, let's bring it all home with question 4, translating these back into radical forms. 5 cubed to the 1/7 power. That denominator 7 swings right over to become the index, so it's the 7th root of 5 cubed. For ab to the -2, all to the 1/3, the 3 is the index, giving us the cube root of ab to the -2. What about 5/7 to the 5/7? Well, the bottom 7 is the index, and the top 5 stays inside, so the 7th root of 5/7 to the 5th. Moving to b over a to the m over 2, that 2 becomes our invisible index for a square root, leaving us with just the square root of b over a to the power of m. Finally, we have this massive messy bracket to the 1/5. Listen, it doesn't matter how complex the inside is, the 5 becomes the index, giving us the 5th root of that entire expression. And literally just like that, the whole shebang is done. You've conquered the entire exercise.
We have covered a tremendous amount of ground today, and honestly, you should be super proud of the decoding work you just pulled off. You now know for sure that a radical isn't some crazy alien language, it is just a highly efficient visual code for a fractional exponent. But I want to leave you with this final thought. If a complex radical is really just a hidden fractional exponent, what other mathematical symbols out there are just secret codes waiting for you to crack them? Math is entirely built on these beautiful, logical patterns. Keep digging for those roots, keep questioning what's hiding beneath the surface, and never stop breaking the code. Thanks for hanging out with me on this explainer, and I'll catch you next time.